This is Catherine Schmer, and in this video we discuss continuity in higher dimensions. Now, in previous videos we discussed limits in higher dimensions, and we'll need that concept in order to define continuity. So a function f of xy is continuous at the point x0, y0 if all three of these criteria are satisfied. F is defined at x0, y0, so your function has to be defined at the point. Limit as xy approaches x0, y0 of f of xy exists, so the limit has to exist at that point. And the limit as xy goes to x0, y0 of f of xy equals f of x0, y0. So in other words, the limit of the function has to equal the value of the function. You can't have a hole in your function and then have the limit approaching one value and your function defined up at another value. So just as a reminder, polynomial, rational, trig, exponential, and logarithmic functions are continuous on their entire domains. So if you have any of these types of functions, you just have to figure out what the domain is. Example: at what points x, y in the plane are the functions continuous? And our first function is f of xy equals sine of -3 over x plus y. So that whole expression, -3 over x plus y, is plugged into our sine function. We know that sine is a trig function, and a trig function is continuous on the entire domain. So now we have to figure out the domain. So the domain we're going to get from what's plugged into the function. We know that we can't divide by 0, and so x plus y cannot equal 0. So that's our restriction, is x plus y cannot equal 0, but everywhere else our function should be continuous. And so we'll say f is continuous on all points other than x plus y equals 0. And we can write this in set notation. We can have the set of all xy in R2, so all ordered pairs in R2, such that x plus y is not equal to 0. So that's called set notation, and that gives the set of all xy where our function is continuous. And if you want to write down how we read that, this is all xy in R2 such that x plus y is not equal to 0. Alright, our next example, g of xy equals natural log of x minus y plus 3. So we know that this is a logarithm, and it's continuous on the entire domain. And we get the domain from what's plugged in. So our domain, we can only plug positive numbers into a logarithm. And so x minus y plus 3 is greater than 0. So that's our restriction. So g is continuous on the set all xy in R2 such that x minus y plus 3 is greater than 0. So you want to remember your restrictions on the logarithm domain are the whatever's plugged in has to be greater than 0. And last example, h of xy equals e to the xy. Now you think about the exponential, there's really no restrictions here, and x times y, you can plug in any xy and get a valid outcome. So we can plug any number into an exponential. So h is continuous on R2, the entire R2. And when we say R2, we're talking about all ordered pairs xy. So remember from the first slide that polynomial, rational, trig, exponential, and logarithmic functions are continuous on their entire domains, and then it's up to you to figure out what is the actual domain of that function.